Now numerical number 5.15, two bodies of mass 10 kg and 20 kg respectively kept on the smooth horizontal surface and tied to the ends of a light string. Horizontal force of 600 Newton is applied to A and B. Both the bodies are A and B along the direction of the string. What is the tension in the string in each case? Okay. Now see, first of all, this is a smooth horizontal surface, so there is no friction. And say for example, you have this is the body, this is the surface rather, and here the first body is there A, the other one is here B. Okay, they are tied with the string and force is applied here. Okay, the body B is of say 20 kg and this is of 10 kg. Now when force of 600 Newton is applied here, then it will produce tension in this string in this particular direction for this object. Okay, so the tension produced is say T1. The force is on 10 kg object. Force is on 10 kg object. Now try to understand, here there is no friction, so the acceleration is force upon total mass. Total mass is how much? 10 plus 20, so it becomes 30 kg. So it becomes 600 divided by 30 and it will be 20 meter per second square. Now try to understand. When you are applying the force in this direction, then the tension in this string is in this direction. Now resultant force on this object, if I want to find, then resultant force is nothing but mass of that object, that is m1. If I say 10 kg, m1 is 10 kg, so I take this as m1. Okay, that is resultant force is mass into acceleration, and that is equal to this force of 600 Newton minus the tension which is produced in opposite direction. Okay, so T1 will be F minus m1a, and that is 600 minus m1 is 10 multiplied by acceleration is 20. So 200 is subtracted from 600 and it will give you 400 Newton tension in the string. Okay. Now you are changing the whole direction of this 600 Newton. Now you are applying the force in this direction on 20 kg object. So what will happen? The acceleration is going to remain same. Okay. Instead of m1, we have to write m2. Now the equation will be m2a. There is a resultant force on 20 kg object, that is m2a is equal to force F which you are applying. Okay, force F which you are applying minus the tension. Okay, and that tension can be say T2, and T2 can be found as force F minus m2a. Okay, and it can be easily calculated by you, and it can be 200 Newton. Okay. Now example 5.16, two masses 8 kg and 12 kg are connected at the two ends of a light inextensible string that goes over the frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. Okay. Again, we can easily calculate this. Okay. Say for example, first of all I am drawing a figure for you. Okay. Say this is a pulley which is kept somewhere, okay, with a rigid support, and two masses are tied. Okay, one is of say 8 kg and the other one is of 22 kg. The other one is of, rather say it is of 12 kg, not 22, it is of 12 kg. Okay, so the tension produced will be in this direction. Okay, for this it will be in this direction. Okay, this mass is m2, so the force in downward direction will be m2g, and here the force in downward direction will be m1g. Okay, now resultant force try to understand. Resultant force can be easily calculated. Okay, the one force is in this direction and the other force is in this direction. So the resultant force will be equal to m2g minus m1g. Try to understand. And this resultant force will be equal to the total mass of the system, that is m1 plus m2, into the acceleration which is produced in the system. Here a is the acceleration of the system. Now you can easily find this value of a to be m2g minus m1g upon m1 plus m2. Okay, m1 plus m2. Okay, and it can be 2 meter per second square. Okay, so resultant force, one is pulling this side, the other one is pulling in this direction. This force is more, this force is less, so the resultant force will be m2g minus m1g. If a heavy body is tied here, light body is here, so resultant force is m2g minus m1g, which produces the acceleration in the whole system. And acceleration in the whole system is say a. Okay, so resultant force is nothing but mass into acceleration, that is total mass of the system multiplied by the acceleration, and you get the value of this acceleration about 2 meter per second square. Okay, now we want to find tension. Again, it is very easy to find the tension also. Okay, say for example you want to find the tension in the string. Okay, again I am drawing the figure for you. This is the pulley and this is the situation how the masses are there. This is the tension T. Now this force in downward direction is m2g. Now resultant force on this object. Resultant force on this object is mass of that object multiplied by acceleration. So resultant force is equal to, try to understand, m2g force will be more than the tension. Okay, so tension can be easily calculated m2a plus m2g rather m2g minus m2a minus m2a. Okay, m2 is known to us, it is 12, g is 10. Okay, acceleration is 2. Okay, so it becomes 8. Okay, 12 into 8, so it becomes 96 Newton throughout the string. Okay, the tension will be same. Now 5.18. okay, we have this numerical 5.18. Two billiard balls each of 0.05 kg moving in the opposite direction with the speed of 6 meter per second collide and rebound with the same speed. Okay, what is the impulse imparted? That we want to calculate. Okay, now again we will use here the change in momentum. Okay, say for example you have the billiard balls which were earlier moving in opposite direction. So one is moving in this direction, the other one is moving in the opposite direction, and initial velocity of this can be taken as vi cap, then this must be taken as minus vi cap. Okay, opposite direction. This is before collision. Okay, now what will happen after the collision? They are moving in again opposite direction. The first was moving in right hand direction, will move in left hand direction. So its velocity will become minus vi cap, and the ball which was moving in the left hand direction will move in right hand direction. So this is after collision, it will go this side. So it becomes plus vi cap. Now impulse imparted to ball 1 due to ball 2 is nothing but change in momentum of ball 1. So we shall find the change in momentum of 1. Okay, so initial momentum of 1 is vi cap. Okay, initial momentum of 1 is vi cap. Initial momentum of the first was initial momentum of the ball 1. Okay, and it was having its initial momentum to be vi cap. So its momentum was mvi cap. Final momentum is minus mvi cap. So it will become minus mvi cap minus mvi cap. So it becomes minus 2 mvi cap. Okay, and its magnitude, if you take, then magnitude is positive 2 mv. We can write only the magnitude. Okay, so if you want to find the magnitude of this change in momentum, that is impulse of force, okay, that is F into delta t is nothing but impulse of force, and its magnitude we want to find. So it becomes 2 mv, and mass and velocities are given. Okay, 2 into mass of the ball is 0.05, because it is given that it is 0.05 kg mass and velocity is 6. Okay, so it becomes 0.6 kilogram meter per second. Okay, now 5.19, a shell of mass 0.02 kg is fired by a gun of mass 100 kg. If the muzzle speed of the shell is 80 meter per second, what is the recoil speed of the gun? See, initially the gun and the bullet both were at rest, so initial momentum of the system is 0, and final momentum is nothing but mv1. Say v1 is the speed of the shell, muzzle speed of shell, plus the other one will be mv2, where v2 is the velocity, rather that of the gun. It is in the opposite direction, and we want to find out v2. Okay, so v2 can be found easily. It can be minus mv1. Here automatically minus sign comes because the velocity v2 is in the opposite direction of v1. Okay, and upon that m1, we can take m1 as a mass of the bullet and m2 as a mass of the gun. Okay, so it becomes m1 v1 upon m2, and you can place the value here minus, say 0.02 kg is the mass of the bullet, and 80 meter per second is the speed, and mass of the gun is 100. Okay, and simplify, v2 will be minus 0.016 meter per second. Okay, minus sign shows that gun moves in the opposite direction of the bullet. Okay, thank you.